All right, welcome back. So today we'll be discussing Chapter 8. Chapter 8 is the first chapter where we'll be discussing structured data type. In the first few chapters, we talked about individual variables and how to initialize values. In Each variable could hold only one value. In structured data type, we'll learn that you can actually hold multiple pieces of data by using one variable, and that's where the concept of the array comes in. So in this chapter, we'll be discussing some of the reasons for using arrays and how do you actually assign and manipulate those values and what is the array index. There's some new terminology we'll be discussing, how to initialize those arrays and some of the restrictions, and how do you pass those arrays to another function, how to do search and sort. And by the way, all of these pieces of code are already available on our Canvas site under demo files. So if you want to search something, especially we are referring here sequential search or linear search, the code is already available. It's only your 2 or 3 lines of code. Sorting such as bubble sort, the code is also available. So you'll find the code is easily accessible online as well as on our Canvas site as well. We'll also, at the end of the chapter, talk about some concept called parallel arrays and multidimensional array. And the reason strings are introduced here because strings by default are arrays. They are built as collection of characters, and they are basically a collection of characters. And then you'll see that how I will demonstrate that strings can be used. So like I stated that the first few chapters, we talked about simple data types. Variables of these types can store only one piece of data at a time. In case of structured data type, especially in this chapter, chapter 8, and chapter 9 and 10 and onward, you will hear a lot of different terminology terms, and one of them is called arrays. A data type in this particular case, data item is collection of other data items. All right, so let's see how we define arrays. And array is a collection of, so I want you to pay attention to this one, fixed number of components and of the same data type. These are the two key terms here. So when you declare an array, it is a fixed number. So the size of the array is fixed at the time of the creation of that array. And all the data in that array is stored of the same data type. So for example, if I declare an array of integers, all the data must be of integer type. Similarly, at the time of the creation of array, I must provide the size. So certain amount of memory is set aside at the time of the creation. And we are referring here is one-dimensional array. One-dimensional array, and gradually we'll learn about two-dimensional arrays and other types as well. All right, let's take a look. How do we declare an array? So to declare an array, we use special operators or special square brackets. These square brackets are called array subscripting operator. And inside the subscripting operator, array subscripting operator or square brackets, we provide an index or subscript. So what it means is here, if I have an array, let's say the array is called numbers, and in my square brackets, I can actually, at the time of the creation of array, I say I want to have 10 elements in that array. And what are the elements? We'll see that just in the next slide or so. And then when I want to access a specific element, specific component, I can use the index. So these are some of the terms. One thing we have to remember, array always begins with 0th index. So I want to highlight this one here. Arrays always start with 0th index. So normally as humans, we tend to start things with 1. The people who created arrays, they decided to start array index with 0. So if you have 10 elements, it's going to run from 0 through 9. It's not going to run from 1 to 10. In fact, the 10 elements, that's how are used in most of the programming languages. So if I create an array of integer type, the name of the array is list, and here I'm providing the size 10. As soon as I run this line of code in the memory, in the RAM, this is what it will be created for us. So the name of the array is list, and you can see the 10 components, or we call them elements, 10 elements. The first index, in order to access the first element, I have to use array subscript or index of 0. To access the last one, it would be 9 because the starting index was 0. So altogether we have 10 components, but the index run from 0 through 9. So to access the last element, it is always size minus 1. If the size is 10, 10 minus 1 is 9. So let's say I want to store something in the sixth location, sixth element. So I can use 5, list 5 equals to 34. So 34 will be stored here. Okay. And if I want to, let's say, store 10 on the fourth location, you can see right there, and on the seventh location, 35, I can do some kind of manipulation here. So in the sixth array element, I can store whatever is found here, add, and we can add them together, and whatever is found in this location. So 10 plus 35, it will give us 45 here. Okay, so the manipulation are pretty similar, like we used to do with the traditional or simple data type. And what are some of the basic operations on one-dimensional array? Well, we can initialize, we can populate by getting the inputs, we can produce outputs, we can find the smallest and largest, and each operation requires ability to step through elements of the array. So it's a sequential array. So if I want to go to the fourth or fifth element, I have to pass through the first few of them. So, and the easiest way to do is by using a loop. And it is really easy to use a for loop because we already know the size of the array. So you can easily use a for loop and you can cycle through. You can actually pass through all the elements of the array. So if the size is 100 in this case, so I can say int I equals to 0, I less than 100, I plus plus, and I can actually get all the inputs, or I can produce all the outputs, or I can process them how I would like to process. An index of an array is in bounds if the index is greater or equal to 0 and less than equal to size minus 1. What does it mean? It means, if you go back to the previous image, so if I want to stay within the boundary, I should not be looking at the -1 index or 10 index. That is out of bound. I should be staying within this range between 0 and 9, or in case of 100, size 100, 0 through 99. That's what it's highlighting here. So in C++, there's no guard against indices that are out of bounds. So if you're trying to access something you shouldn't be accessing, so although it is logically it is incorrect, and sometimes the compiler will also give you the error message. Now, how do you initialize them? If you have the size not known, for example, but you have the initial values, you can actually put those initial values in curly braces like this and end with a semicolon. And then in this case, it will calculate the number of values 1, 2, 3, 4, 5, and the size automatically becomes 5. And this array is of double data type. All right, that's one way to do it. And then also, if you want to initialize all the elements to 0, this is the best way to initialize all the elements of an array of integer type into 0. Now notice that in this case, the size is 10. But we only have 3 initial values, 8, 5, and 12. Those 3 values will be populated in the first 3 elements, and rest of the elements will get 0 automatically. So in this case, the first 3 will get 8, 5, 12, and element number 4 through all the way at the end will get 0 initial value. So that's another way to initialize as well. Okay. So here declares an array of 10 components and initializes to, so 8 goes to the first location, 5 goes to the second location, 12 goes to the third location, and rest of the components, they get 0 initial values. Now you can you can have any operation that manipulates the entire array as a single unit, not allowed in case of arrays. What does it mean? It means if I have array called your list, which is shown right there, created with a size 5, and my list, which is size 5, and my list has some data. Your list does not have a data. So if I want to assign all the data of my list to your list, I cannot do in this format. I cannot say equal sign. Why I cannot do equal sign? Because these array names, they hold the memory addresses. They are not they don't have the ability to do aggregate operation. But if you want to assign all of the element data from one list to another list, you have to use a for loop like this one. So here, zeroth index of this one, and pick up the data from zeroth index from this one, and it's going to cycle through this with this process. So if you pass the arrays to another function, by default, they are passed by references. If you remember in chapter number 6, we learned about functions. You can pass the arguments by value or by references. And typically, when you want to pass by references, you have to use ampersand sign. But if you pass by value, and then you have a duplicate copy on each function. In case of arrays, none of these things exist. Automatically, when you pass an array, it is passed by reference, and you don't have to use the ampersand sign at all. Okay, and once I actually demonstrate that one, it will be visible to you how that is done. And here is a function, and in this function we are passing two arrays. One is called list1. How do I know it's array? By looking at the square brackets. And the second array is called list2. So those two arrays are by default passed by reference. And what does it mean by pass by reference? It means function A and function B, main function and this particular function, they are looking at the same memory location. That's what it means by pass by reference. It's also called pass by address. So can prevent a function from changing the actual parameter when passed by reference. So if you're afraid that Y array should not be modified, and if you want to pass that Y array to some function such as example in this case, you can actually put a constant before it. So in that case, by using constant, that function will not be able to modify Y array in this case. So you can actually keep Y array intact. But X array can be modified because X array doesn't have the constant with it. So the base address of an array is the starting address of the first element of the array. An array are contiguous in nature, which means in the memory, if the size is 10, the first element of the array is connected to the second and the third and so on and so forth. If I can get to the first address or first element, which has the base address, I can access all the other neighbors. So if I can get to the first element, which is index 0, I can access the next one and the next neighbor and the next neighbor and so on and so forth. So that's what it's highlighting here, that having the base address, access to the base address will allow you to access all the elements of an array. So C++ does not allow functions to return a value of array type. Honestly, we don't need to return anything because automatically when you pass an array to another function, it is automatically passed by reference. So if you make any changes to it, automatically the changes will reflect in the previous function as well. Here it's just showing you enumeration. Enumeration basically means these are different colors, or it could be different months, and they have a value of 0, 1, 2, 3, and you can actually do a listing in this manner as well. And here we have an array of size 20. Number of students are 20. Now, if I do not have a constant here, and if I try to put a variable, it's going to give me an error message, because the size, for the size, it should be a fixed amount. It should be a constant. But if I try to put a variable there, it's going to give me an error message, and I'll demonstrate that one for you as well. Now, when you have a lot of data in arrays, you should be able to do search. And the simplest search is sequential search. It's also called linear search. You can compare the first element of the array. If the value matches with the criteria, that it means you found that data. Otherwise, you can actually continue to cycle through the entire array. All right, and that is called sequential search. If the value is not found, and at the end, we'll actually send a message, the value is not found. Similarly, sorting means we are rearranging either ascending order or descending order. So ascending order is smaller to larger value, descending is the opposite. So we'll learn about bubble sort and I'll show you the algorithm for the bubble sort as well. Okay, in this case, sorting is happening and this is the selection sort. So it's trying to bring the smallest value and swapping the smallest value. And I'll demonstrate that for you as well. And let me see what else I need to show you. Um, an array whose components are character, a single character. What if you have that array, then you have a lot of textual data, and that is how the strings were formed in C++. The original C language did not have the string library and did not have strings, so collection of characters actually allowed us to demonstrate as strings. So here we have name. Name can hold up to 16 different values, and this is called C string. And instead of doing this, we learned in the previous chapters, we can declare something like this, string name. And then we can have 16 or more characters for the string name. But because the original C language did not have the strings, so this is how they actually used array for the string data or textual data. Now in this case, this is also char or character, but notice that this time it is basically giving you double quotes. So, and many of these functions exist in the string library, like a string copy, string compare, string length, and so on and so forth. And I'll show you how the strings are used in case array. And you can also compare the strings if one string is greater or smaller than the other string. You can use the string compare function as well. And most of these rules will apply to string libraries, and in fact, strings are very easy to compare as well. And we did that in the second project, I believe. We know how to read the data, and we can read the data and use some of the existing function. You can also display the data, and we have done these things before. And we have already know how to open a file. And then in this case, it's just showing you that you can convert one type of string to another kind of string. And the concept comes here in this slide number 35 is when you have two arrays which are they correspond to each other. They're kind of related to each other. For example, student ID and student grade. So the individual who owns this student ID, this ID, has this grade. So the information should be stored parallel to each other. Where you declare two separate arrays, like this one is an integer array, this one is a char array, but you store corresponding data into it. Although they are not, technically they're not connected, but in your logic, you keep them together. Okay. Then how do you declare two-dimensional array? Just like your single-dimensional array, let me see if it shows you right there. So in single dimensional array, you had square bracket, one of these sizes. If you have two of those square brackets, then you have two-dimensional array. Two-dimensional array means 5 rows and 3 columns. So first you have number of rows, then you have number of columns. So if you want to look at it, so we have in this case size 5 by 3. So we have this one is not a good example because here it's showing the column number 3 and size is row number 5, but actually we have 10 rows here in this case. But you get an idea. So you have the first row, the second row, third row, and so on and so forth. I'm sorry, this one actually is showing you the accessing of this particular location. So in this case, the sales is size 10. Does it show? No, it did not show size 10. So size 10 here and 5 columns here. So this one is just showing you that it can access or modify a specific part of the part of the two-dimensional array. They can also be initialized in a similar fashion like we saw earlier. And what else I need to show you here? I'll be showing you my demonstration. And here it's basically showing you can actually go to a specific location and you can store the data in that location. Ways to process for two-dimensional array, you have to use two for loops instead of one for loop, one for the row, one for the column. And it's showing you how to initialize the data. You can see matrix and row initially it is 0, column is initially 0, assign 0 to it. Then column becomes 1, then assign 0, 1, then 0, 2, then 0, 3, depending upon how many columns we have. Once we have completed all the columns, then the row becomes 1. When the row becomes 1, then 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, and so on and so forth. That's how you can initialize all of the data. And you could do the same thing for printing purposes as well. Again, make sure you have two for loops, one for the row, one for the column. And you can cycle through all of them. Really, really simple stuff. For our project number 7, we'll not be using two-dimensional arrays, but they have been explained over here. And reading the data is very similar. You have to use two for loops to read the data for rows and columns. You can do summation, sum equals to sum plus whatever the data you have in each row and column. And you can do sum by column as well. And then how do you find the largest value? We did that in one of the examples. You can assume the first deep data set is the largest value, that you can compare that one with the rest of the elements values. Similarly, two-dimensional arrays are passed by references as parameters to function. Base address is passed to formal parameter, are stored in row order. So just like the way we pass single-dimensional array, we can also pass two-dimensional arrays. It's just talking about strings are by default arrays, but strings can also be declared as arrays as well, which I'll be demonstrating as well for you. What else I need to show you? And you can have three-dimensional arrays, which we will not be using in our demonstration. All right, let me see if I can share my screen with you, and let's go and share the screen. All right. All right, so now you can see my screen. If I want to declare an array of integer type, number, let's say size 10, that's how you can declare it. Okay, this is the size, if you remember, fixed number of components, size 10, and same data type. How do I initialize it? I can initialize it. This is the preferred way to initialize, curly braces, open and curly braces close. All the 10 elements will be initialized to 0. But if you know the first one or two values, 10, 20, so the first element will have a value of 10, the second element will have a value of 20, rest will be initialized to 0. Okay? All right. How do I initialize or create double data type array? All right. So let's say this one is called value, and this is size 10 as well. Let's make it 5. All right. How do I initialize this one? Equals curly braces 0, 0.0. If you need to initialize that. Can I create a char array? Middle initial, 100 middle initials. How do I create a Boolean? Boolean flag. And let's say size is 4, whatever the size is, doesn't matter. I'm just trying to show you they are not related or connected to each other. Now, strings can also have arrays of them. Strings are by default arrays, but they can also be declared as arrays. So let's say there are 10 names. Okay. Now, if I want to read the data, in case of, let's make it smaller, 10 is too large, just to save some time. So I can create a for loop. For loop is ideal for these kind of arrays. I equals to 0, start with 0, I less than 5, I plus plus. Okay, that's my for loop, which is going to run 5 times. And I want to populate all the data. So I can say cin, num, and I. So this will allow me to populate the data, but I should prompt the user. I should ask the user for this data type. Please enter a number. So user knows exactly what we are asking for. Once that is done, and then I want to copy this for loop right underneath here, just to show you. So we should be able to display this content as well. Number I, and let add a space there. And let's run the code. So when I run the code, it's asking for the first number. Let's say the number is, let me pause this one and read on the code again. And let me pause this one again. Sometimes these online compilers give you trouble. 45, 32, some data here, some negative values, and 3. And now you can see I was able to populate all the data in that array. And here I was able to display and verify the data. Now, what if I want to read this data in a separate function? Well, let's create a function called void read. And I want to put that particular loop in that function. So the data should be read here. This for loop is going to run here. But this function doesn't know anything about num. So I will say, okay, I'm going to pass you this num array. This num array will be passed. Then I call that function. That function is called read. So I'm going to pass that function num. That's how you pass it on. Because arrays are passed by references, all you have to pass is the name of the array. The name of the array will be captured here. And because they automatically pass by reference, whatever I populate in this function, it will automatically reflect in the main function. That is the beauty of an array. So, and then I should copy this header of the function, paste it above as a prototype so compiler is not confused. All right, so I'm making a call. I will jump over here, populate all the numbers, and then I will display the values here. All right, let's test it. All right, so some fictitious data here. And when I hit 7, watch what happens. I come back and the data is automatically displayed here. Notice that the data was populated somewhere else, but it was visible to the main function. And that is because arrays are automatically passed by references. Without references, this is not possible. Okay. Now, if I want to show you, just to prove my point, let me just prove my point. If I show number in both places, number is basically the address where array exists in the memory. And if I do the same thing on this side, I'm just displaying the address of that array where the array begins, and that is called the base address. Show me the base address, and it shows me the base address right there. It's exactly the same. That proves our point. The base address, because it is passed by reference, it's going to show you exactly the same location. Now, let me see if I missed anything for the simple array. I'm just double checking if I missed anything, and looks like everything looks good. Okay. So I already mentioned base address, passed by reference. I'm just double checking here. Oh, let's do the search. All right, so here I want to call another function. Let's call that function. I have to pass. By the way, let me also show you when you go to, let me just comment it out, this part here and share my screen. So when I actually demonstrate anything, everything is already available to you. So if you don't capture anything, if you go to one of the demo files, and you'll find my display array here, my modify array, change array here, here's my search array, and here's my and a search ID array, and there's a bubble sort over here. So all the programs are already available to you. So you can simply copy them and paste them. And in fact, let's actually do that while we are here. You can simply copy the entire code. You can test it out. You can copy it, open another online compiler. And when you have another online compiler, you can simply paste my code there and make some space and go ahead and run it. And if there are no errors, in this case, it's not recognizing certain functions because online compilers, they have limitation. So on line number 81, it's telling me I don't understand get.ch. So you can go and comment it out. So it might not understand a couple of other things as well. So if you get these error messages, just comment them out. And one or two, same thing. So if you ever find something like that, just comment it out. And 131, because I use this one in Visual Studio, so Visual Studio has some built-in functionalities which are not visible to online compilers, so don't worry too much about it. So a couple more, 203, we need to comment it out, and then it runs successfully, as you can see. I think you can see my screen, but if not, then let me share my screen again. And I think you can see the screen. So this is after I commented out key equals to get ch, you should be able to run that program. And it has built-in search criteria, built-in sort criteria, search by ID, fill in array, which is populate an array, display an array. Right now, there's no data in that array. It's going to say, well, there's nothing to display. If I do number one, and when I say, and by the way, it's also saying CLS is not found. What does it mean? I have also added another functionality, system CLS. You can comment out that part as well. Okay. Just wanted to show you that option right there. Okay. And let me go back and double check. Okay. So now what I want to do, I'm going to demonstrate a simple search for you. So here's my simple search. And in fact, in this case, if something is found, I'm going to send true or false based on what is found. And my function is called search. I'm going to pass this num array, just like I did with the previous function. And here's my search function. So I'm going to copy this header, put it above the main function, and put a semicolon at the end. Then when I call this function, let me call this function underneath here, search, and I'm passing this num array to that search function, and it will have the full access. So in the search function, we come here and we ask the user, what do you want to search? What number would you like to search? So we will capture that number from the user. Let's say the user says, I want to pick up this number, and this is my search number variable, and this is not declared yet. Let's go and declare it, search number. Okay, so we are going to search that particular number, and because arrays are passed by references, I have the full access to this array. So I'm going to go and cycle through this entire array. So let me copy this for loop. In programming, by the way, I have mentioned that a few times. There's a lot of copying and pasting. It's okay. It's your code. You can copy and paste. So here, how do I search? It's called sequential search or linear search. So I'm going to compare with if the first element num I equals my search number. I'm comparing each one of these elements. If the number is found, I will mention that one here. So if the number is found, I can say number is found. Is found. And I can be more specific, but here just to keep it simple, I can give the specific number. I can display that number. I can give the record number or the index number. I can be more specific, but here we are just saying number is found. And then I can continue to search or I can stop at that time. If that's not the case, if the number is not found, I can simply say cout, not found. All right. Okay, so once that's done, and I can return something back here. Let me just make a void function first, It's a void function. Then I'll make it a Boolean function and I'll return something back at that time. So make sure you copy the header, put it above the main function with the change. Okay. So now we call the search number function here. The array will be passed here. Then we ask the user what do you want to search. We compare each one of the elements in a sequential order. If the number is found, we will say number is found. If not, then it says number is not found. All right, let's run it. If there are no errors, it should run smoothly. So let's say we have this array. We have just random numbers in that array. And this is our array, 5 elements. Our array is pretty simple. Hit enter. These are the numbers. I forgot to put ENDL there, but that's okay. So we want to search successfully first. So let me see if I can search -567, something in the middle. And then when I hit enter, it says not found, not found, number is found. Why do I have that so many times? Because every single time, if the number is not found, it displays not found. And if the number is found, it says display, it displays number is found. Well, that's not very kind of nice looking. So what we can do, we can actually have a Boolean variable right there. That's where we can use a Boolean flag. Initially, the flag is true. Actually, let's make the flag false. And once the flag is false, if the number is found, we can say flag equals to true. True. We make it true. And I'm going to remove this one from here. And again, there are various ways you can handle this one. Uh, I'm just showing you one way to do it. I'm going to leave this one there for a second. And if the number is not found, I'm going to keep my flag false. Okay. So when the number is found, we say true. And we can be more specific. We can say, well, it is true. So I can display that message. In fact, you know what? Let me keep this message here. Keep that message there. If it's true, it says, and if it is false, if flag equals false at the end, we say not found. And again, you can do different ways. This is just one way to do it. And here I'm going to put an extra ENDL to avoid to have an extra line. Let's run the code again. And this time I have this data. And this is my data right there. And now you can see there's an extra line as well. And what I will do, I will search for 23. This ad needs to be closed. Okay, 23. When I hit 23, oh, still it says not found. The reason is because I was supposed to do this outside of the for loop. I thought I did it outside the for loop. For loop ends right there. It should be done over here, outside of the for loop, not inside the loop. When you do it inside the loop, it's gonna, every single time, it's gonna display the same message. All right, let's try one more time. Let's run it. And by the way, this is perfectly normal when you're learning programming. You have to go in a sequential order and run through different cycles. Let's see if we can search 7. And this time it says number is found and not found at the end. Why did it say not found? Because because of this problem. We should not have said that. Okay, that's better. One more time. My logic was not coming along. One more time. And hopefully it will work this time. And then this time we'll say 7. Look for 7. And it says number is found. And if I run the code again, just to show you, I have to stop this one and read on the code. Okay, let's try one more time. And this time I'm going to search which does not exist. I'll search for 90. 90 is not in my array. And this time it says not found, as you can see. Okay, same thing for when you're reading the data. Let me just show you when you are in your lesson. Let me see if this one is being covered. Let me just double check that one. So when you go to the project for project number 7, so it's going to ask you to read 5 candidates and their votes and their percentages, calculate their percentages. So you're going to use a string array to store their first names. You're going to use double array to store their number of votes received. And then you can calculate the percentage. Once you have all the votes in place, add them together. That will give you the total number of votes casted. And when you divide each individual vote, 5,000 divided by 19,300, you'll get the percentage votes received. So you're going to declare 3 arrays. One array for the string type for the names, one for the total votes received, one for the percentage votes received. Then you will find out who the winner is, which basically means you'll compare the first number of votes with the second individual and the third and fourth. You'll find which individual has the highest number. You can actually find the winner by looking at the votes received or the percentage received. Either way is fine. Like in this case, Duffy has 6,000 votes or 31%. Duffy is the winner of the election. All right. So this will allow you to complete our project, and we will stop right there. And thank you, and I'll see you next time.